an overjet. This can be corrected maybe with class 2 elastic. So if we are going to do extraction, let's say we are not going to do extractions. Inclination of the cannon here a little bit. We have also an occlusal plane that can help us see. So the level of the cannon should be a little bit down. This, you see that is hanging. This can be removed, or it can be intruded a little bit, but we have to check here the free gingiva. We want them to be at least the twin sizes at the same level. Here maybe, okay. The best thing to do is to have both dental arches customized in order to be able to create a nice setup, not only the dental arch, the upper dental arch, like here. Here I'm doing it just for purpose of presenting the software. I don't want to start doing also the lower and then lose time. Okay, let's say that now we are okay. This will be removed. This will be fixed afterwards. Okay, now what we are doing, we are choosing custom printable brackets, maxilla and labial. We have a lot of brackets, kind of brackets. These are the standard, as with this is 18 by 25 slot. We will use also afterwards 22-28, but not now. And large parts, some parts are bigger. These we did it because with composite resin, with ceramic resin brackets, not zirconia, we needed a little bit bigger in order to have more strength. And large parts, only the slot was bigger in order to counteract the constriction of the slot upon printing, because we had some constriction while printing with the resin brackets, and a large slot and the only 2 wing brackets, not 4 wing. Now what we did, we named zirconia brackets as tough 10%, 20%, 30%. What is this? Tough, like you see here, it's exactly the dimensions that we want, 18 by 25. But because when we are printing with zirconia and regularly, like ceramic and metallic printing, we get some constriction of the parts in the slot. I thought that we could design something that will be the slot at least 10% bigger. This is a slot with 10% bigger dimensions, 20%, 30%. I use mostly 20%, to be honest, and I find that is quite accurate. So let's say that we do a 20%. We do positioning. We have now the brackets with a wire in the position that is approximately opposite to each tooth. Now we are able to see if the brackets are too near to the gums or too near to the occlusal plane. On the right side, on this side, is very nicely aligned, not near the gums, not near the occlusal, but here it is. So what we can do, we can take this manipulator and rotate a little bit the brackets, move them a little bit up. You can see here that we are also a little bit towards the occlusal surface, so we can easily move the brackets a little bit like this. And if we want, we can move this manipulator at the front so that the center of resistance of rotation of the system will be here. So I can do this. It's too much. I wanted just to show you what we can do. I will take it a little bit back. So with this central manipulator, you can do whatever you like. Okay. Now, another thing, we need to move the brackets as near as possible to the tooth surface. We like to have small, thin bases for biomechanical reasons. As you can see, as we are moving the brackets, the wire adapts also. You have to have an equilibrium between, can rotate it, between, you have to have an arch wire which will be not with many bends. We don't like many bends, so we want to move the brackets in a position that the arch wire will be more or less oval. Here we can rotate this bracket, move it like that. The same thing here. The next step in this software will be artificial intelligence, but until now we are dealing with other things. Artificial intelligence for sure will help doing the segmentation even a little bit faster, but also doing the setup, let's say 70% perfect, and the rest the orthodontist will do, and the positioning of the brackets will be also much, much faster. So this side, I think more or less, if you forget this here, it's because of the scanning. This is a case for lingual brackets, so I did it from inside. It's not for labial. Here you can see the wire goes a little bit outwards. The bracket needs to be moved a little bit lingually, not so much. Here the bracket, I think, is in a good position. But here, no. As we're working, if we don't like something and we are able to move this tooth, like here, we can change the inclination a little bit of the canine because I did it a little bit too much, so that now it's better. Okay, it's a nice alignment of the brackets, I think. Can see that is fast, even without artificial intelligence. Maybe here we could move a little bit the bracket outwards, labially, just to have a better arch form. Sorry. And maybe rotate. You see, now it's more oval. Now we just have to press. Let's press extrusion. Let's do save, please, first. Extrusion. Extrusion means that now we have also the brackets with our bases and the tubes, which we would design also double tubes for anyone that wants to do intrusion arches, extrusion arches. We are finished. We go now to the next step. We can do, sorry, a color map to see if we have some collisions with the mandible. Anyway, we didn't use any lingual brackets. With the lingual brackets, this is very helpful, or with the setup also. With the lingual brackets, you can see the lingual brackets inside and these colors, depending on the distance that you have the collisions, the